8.19. Expand the function f of x equals 1 over 1 minus x to the k for 3 different values of k. So let me write the functions first. K equals 1, we have f 1 over 1 minus x. For k equals 2, we have f is 1 over 1 minus x squared. And for k equals 3, we have f is 1 over 1 minus x cube, right? Now you can try, compute the derivatives of all these functions and evaluate it at 0. Well, when they say expand, what they mean is to write the Taylor series for this function at center at 0, right? For this one, we already know it, right? Because this is the, let's call it f1, f2, and f3. f1 is just the geometric series, right? This is from n equals 0 to infinity of x to the n. Okay, and we know that the radius of convergence is in minus 1, 1. Okay, this is true in minus 1, 1. Right. You can try and compute the derivative of this and get a similar expression, but here we want to get use of the fact that the derivative of a function, the series of the derivative is the derivative of the series, right? So we have this function f. If we compute the derivative of f1, right, f prime, this is 1 over 1 minus x squared times minus 1, but then times minus 1 times this. So this is the derivative of f1 is f2, right? If you compute this. So the series for f2 is just the derivative of the series of f1. Or in other words, this is the derivative of this. Okay, and if you compute this, you can do it term by term. You get from n equals 1 to infinity of n times x to the n minus 1. Again, and the radius of convergence is the same in minus 1, 1. Okay, this is what this theorem about derivatives says. Okay, now interestingly, if you compute the derivative of this is f2 is 1 minus x to the minus 2, right? The derivative of f2 is minus 2, 1 minus x to the times minus 1, because this is minus, right? So this is 2. And you can see that we do that by 2. So the series of f3, this is just f2 prime divided by 2. Or in other words, 1/2 of the derivative of this series, the sum from n equals 1 to infinity, right? And it's a derivative. So this is equal to 1/2 of the sum from n equals 1 to infinity of n times n minus 1 x to the n minus 2. Okay? And if you want, you can rewrite this as this as well. You can write this like this: the sum from n plus 1 x to the n from n equals 0 to infinity. You can write this as the sum from it's n plus 1, n plus 2. This is it, from n equals 0, n plus 1 times n plus 2 x to the n. If you want to write it in terms of x to the n. Okay.